We got some stickers in the mail. Thanks everybody for stopping by. Let's take a look at these stickers and then we'll jump into the project. This one comes from Jim's workshop in Minnesota, and I think he's really into model engines. I know he's got a bunch of them there on his site, some really cool models. He's also got a really interesting Benchmaster milling machine. Pretty cool little machine. And he's got a bunch of Atlas drill presses and I think a couple other drill presses as well. He's well covered in the drill press department. And he's got a South Bend 9A lathe. So check him out, give him a sub, a thumbs up, really help his channel out. So the other sticker is from Mick's workshop, and he's in New York. I'm not sure what part of New York. And he's got a shop in a garage along with a car, and the amount of equipment that he's packed into that garage is unreal. I mean, if you want to know how to fit a lot of machines into a small space, check out his channel, and it's very well organized. And he's also got a lot of really cool gadgets he's made. So give him a thumbs up and a sub, check him out. All right, let's go take a look at the project. Let's see how well it's been adhering to the Weight Watcher program. If she's over 200 pounds, we're SOL. Not sure how well this is going to be balanced here. I haven't tried a test lift yet. Uh-oh, she's a heavy one. Well, there's 200. Not quite off the ground yet. I don't know if this scale will keep going. Oh yeah. Okay, we're getting some levitation here. Well, that's like 220. Okay, I've got one lined up. All right, well, that took a little bit of finagling. Okay, let's see how it's going to be to move this thing. I already raised the back up. Crank up the front wheels here. Definitely takes a little more effort now. Okay, that ought to be good enough. All right. Ooh, okay. Definitely got some weight to it now. It is rather top heavy, so I'm just being careful not to overdo it. We're going to try it here for now. Well, next step is to start evaluating, figure out what we're going to do as far as cleanup, any repairs that are needed. The color match is not that great. It's a little off, so I don't know how much I'm going to repaint. We'll just kind of figure that out as we go. So I actually got more room than I thought I would have. So when the beast is in here, it takes up a lot of space. I think the first thing we're going to do is take the motor off. Now I tried running the motor, and remember how bad that power cord was? And it did not run. I'm hoping that it was just something broken. I mean, the wires are literally just shredded. So I'm going to start by popping this cover, see what we have for electrical connections. I have no idea what size motor this is. It looks like a 1/2 horse, and in the literature it says they either came with a 1/3 or a 1/2 horse. And I do have other motors. This one, you know, fits the machine very nicely. The other one that I have is a significantly larger, although I think it would fit, and it's a 3/4 horse instead of a 1/2. And one of the viewers did comment that he put a larger one on his and it made a big difference. I don't know if I want to do that yet or not. I mean, a larger motor might overstress some of the components in the machine, but let's just check this one out first. Yeah, there's no nameplate of any kind on this motor. So, I mean, it's been repainted, so that's probably what happened. And then this electrical cover plate here looks like it was shop made. So there's, I just cut this cord off. And look how rotten it is. Okay, so here's the neutral wire. Okay, and it's going out to our switch, which is wrong. Here's the other side of it. Just barely hanging on there. The hot, look at that, completely exposed. The hot is coming down and landing here, okay? Alright, so just a FYI, so you never switch a neutral. You bring your power in through your hot, go through the switch with your hot, back to the motor. Neutral goes directly to the motor, so that's definitely a no-no. Alright, let me, I'm going to make note of our connections here, and then we'll get things unhooked. Here's the other thing, guys. There's the ground wire. Not even connected. Okay. Alright, I'm checking the on-off switch. Okay, off, on, off. Okay, not bad. The first couple times I did it, I was getting a lot of resistance, but just, okay, I'm wiggling the switch. Okay, so this switch is probably not in the greatest condition, although it's getting better. Okay. The wiring going to the switch is horrible. We're going to be replacing that. Okay. Yeah, I'm just curious if maybe the switch was the reason it didn't run. But yeah, we'll get over to the bench and we'll find out. Okay, we're looking at our electrical connections here. Ooh, that's kind of bright. Okay, there we go. How's that? So our line voltage hooks up to this terminal here. I don't know if you can see it, but there's a letter L way down there and L up here. So that's your two line connections. Probably hot and neutral, or both hot if it's wired for 230 volt. And then you got this black one and this red one are on terminals, let's see if I can read them, 3 and 5. Okay, so these two go to the start windings, and they also go through the centrifugal switch and the capacitor up top. So to reverse the motor, you would just switch these two wires, I'm pretty sure. There's no diagram on this motor, but I'm pretty sure you would just switch these two. And then this is already wired for 120 volt. To run it on 230, 240, I believe you would remove this cross tie here between these two screws, and then there's one down here that you would remove between these two. And you would feed it with 230 volts. Okay. All right. Let's do a little continuity and ground check here. See if I can. I'm going to back you guys up just a little bit. All right. So I've got my meter set for ohms, and what we're going to do, first thing we're going to do, if I can do this all with one hand, we're going to ground, and we're just going to see if we have anything shorting the ground. So ground to our line input up there is okay. Start windings, okay. This terminal, okay. And then this one down here. Okay, nothing to ground. Well, okay, let's do that again. Let's turn the meter on. There we go. All right, let's see if I can just get this to stay in there. Okay, so we're going to check the ground. So our line terminal up there is good. These are good. These are good. Oops. Keep our ground connection from falling out. It doesn't matter which polarity you use. Okay, so nothing there. All right, let's go to the highest scale we have and try it again. Just a little tiny wiggle of the meter, which is okay. And our ground keeps falling out. All right, let's just do continuity. All right, so we should have continuity between our two line connections. Let's try that. This is not easy with one hand, guys. We'll do it like that. Okay, so we got continuity, okay. This hasn't been powered up in a long time, so I'm not worried that there's any residual voltage here. But anyways, here's our start capacitor. It is a 233 to 280 microfarad, okay. That's fairly decent size. There's really no polarity on these. Go ahead and unhook it carefully here. Okay. You only need to really unhook one side. Okay. So now to determine if this capacitor is any good. Now I've got another meter that will check capacitance directly. But if you just got a standard meter, here's how you do it. And we're not going to be able to verify the capacitance. We just want to make sure that it does have some storage capability. So I'm on my highest scale. I'll zero it here. We're on the ohm scale, by the way, guys. Okay, all right. And this works better with an analog meter than a digital meter, unless you have a digital meter that can measure capacitance. Okay, so what we're going to do, we're just going to go across the capacitor. And let's see what we get. Okay, that's exactly what you want to see. You want to see it, you know, in a short burst, show connectivity, and then fade off. Okay, so notice the second time it only jumped a little bit. That's because we've charged this capacitor up with voltage from the meter in this polarity. Now, if I take my meter leads and I reverse them, and I go back to the capacitor, we should get probably even a little more dramatic effect this time. Can you guys see me okay? Let me raise you up a little bit here. Okay. All right, so here we go. So I got the meter leads reversed. Bam. See how dramatic it was that time? That's because we had some voltage in the capacitor in the opposite polarity as our meter, so it really hit it hard. It actually went less than 0 ohms, okay? And that's exactly what you want. So this is a good capacitor, okay? Because we've demonstrated it can store a charge. It will conduct until it stores a charge. And as long as it's not leaking or anything, you're good. Now on a smaller capacitor, you may not get much of a reading. This is a high capacity capacitor. It's a starting capacitor. Sometimes you'll have a run capacitor that's only like 5 or maybe 10 microfarad. You can still get a little bit of a reading, but not as large of a reading that we saw here. But that's the process. Okay. All right, what I'm going to do now is put this back together. I'm going to temporarily hook up an extension cord and see if this thing will run. Alrighty, here we go. So we got a little pigtail cord hooked up here. We even hooked up the ground. So my workbench power is GFI protected, so we got some protection in case things go bad. Alright, so we haven't tried this, so we're going to see it live and in color here if something goes wrong. Alright, here we go. I'm just kind of reaching and staying as far away from it as I can. Oh, there we go. That's running nice. I don't know if you guys can hear it or not, but that thing is smooth. Okay, let's try, give her one more try here. Okay, here we go again. Sweet. All right, so this motor's good. I do want to try to do a little research and see if I can figure out what size it is. Let me give it another look over and see if I can find. Sometimes they'll stamp a model number in them, but so far I haven't seen anything. Motor cleanup is complete. So I did have to make handheld here, guys, so sorry about the jerkiness. I did have to make a new cover plate for this side that was missing, and that's where the all the data would be, nameplate data and so forth. I did find an example on the web after a lot of searching, so if we want to replicate that, at least I have a photo of one. I don't know if we'll get that ambitious. I'll put it up at the end here so you guys can see what it looks like. But yeah, we got it cleaned up, and we did a Earl Scheib's paint job. So yeah, I'm just going to put this away someplace safe, and then start planning what we're going to do next. Probably going to be the counter shaft with the belt shivs. I want to take that apart and get those bearings checked out. So, all right, so we're going to end this episode here. I'll throw a couple stills up here at the end. But anyways, thanks for sticking with this, and hit that thumbs up and subscribe button if you enjoyed this. And we will see you guys on the next episode. Alrighty, thanks again.